welcome to True Projects. In this video, we are going to explain about the project that is a semi-supervised learning approach to quality-based web service classification. Before getting into the execution, first let us understand what is the project about. Web services have become a core part of how modern software systems communicate with each other. They follow a structure called service-oriented architecture, which allows the different softwares to interact and share functionalities. So the idea behind this SOA, that is service oriented architecture, is that these devices can be reused, combined, or integrated into different applications, making them very versatile. However, as more and more companies and platforms provide similar web services, it becomes harder to choose the best one. For example, many services may offer the same functionality, but their performance quality can vary, such as differences in cost, availability, speed, and security. So choosing the right one becomes especially tricky when you need way to weigh all these factors. So this is where service brokers comes in. They essentially act as a middleman, helping users to select the best service by comparing all these different factors like how secure a service is or how much it costs. Service brokers make sure that the most suitable service is chosen based on the user needs. And to make this process even easier, faster, machine learning and data mining techniques are used. These technologies helps to automate the selection of web services instead of manually comparing each option. The system can analyze data and make smart and accurate decisions. And this automation not only saves the time but also ensures that user get the best possible service based on their specific needs and requirements. Manually, Manually labeling web services based on factors like cost, security, performance is time consuming and also costly, especially at a large scale. Supervised learning offers high accuracy but requires large label data sets, which can be difficult and expensive to obtain. On the other hand, unsupervised learning doesn't need label data but struggles with the accurate classification. So, the semi supervised learning which combines labeled and unlabeled data, offers a promising solution by improving the accuracy without needing extensive labeled datasets. However, with this existing semi-supervised methods, they are affected by mislabeled data, which can reduce the performance and also the accuracy. Mislabeled data confuses the model and degrades its ability to classify services correctly. Addressing this issue is crucial for enhancing effectiveness of the semi-supervised learning. By developing more robust methods to handle mislabeled data, we can improve the classification accuracy and reduce manual labeling efforts. This would make it more feasible to classify large volumes, large number of web services efficiently, ultimately improving semi-supervised learning that can lead to more accurate and cost-effective web service classification. Moving on, the proposed system is designed to improve how web services are classified using semi-supervised classification algorithms. So this project proposes a semi-supervised web service classification algorithm, that is SSL-WSC algorithm. What makes the system special is that it can work with just a small label data set and still predict labels for much larger set of unlabeled data. This is especially useful because it reduces the need for a huge amount of manually labeled data, which can be time consuming and also costly process. The system assigns a performance based label to each web service based on its performance. So, the categories which are classified into platinum, gold, silver, and bronze. So, these four categories helps to easily identify which services are performing the best and which services are performing poorly. So by using this approach, the system can classify a large number of services more efficiently while still ensuring high accuracy in predicting their performance. And to make the classification more accurate, the system uses distance functions that is called Mahel-Lonebis distance. So this technique has been used as the main one. Essentially, the system calculates four different scores. So four different scores have been calculated to determine its performance category. So coming to the first score, it is the sum of the absolute differences between all the class labels. This helps to identify this helps to understand how far apart the different categories are in terms of characteristics. And coming to the second score looks at overall distance from each class label, helping to measure how close or far each web service is from the different performance tiers. Then comes the score 3. The third score is the minimum value from the first two scores, essentially identifying the smallest difference or the closest match between the data points and the class labels. Finally, the fourth one. It is called as confidence score. It is a combination of first three scores calculated as a sum of first two scores divided by the third score. So by focusing on the data points with the highest confidence and the lowest distance, the system ensures that servers are classified as accurately as possible. The system's performance is evaluated using accuracy, precision, recall, and F1 score. And moving to the extension part to further improve the performance, CAD boost algorithm is employed in this project. It is a gradient boosting technique that is particularly good at handling categorical data, which is common in real world datasets. It is known for being efficient and delivering high accuracy, especially when compared to the other algorithms. By integrating CAD Boost, we aim to make our web service classification system even more accurate so it can better handle the varying type of data it encounters. Additionally, Additionally to the algorithmic improvements, we have developed a front-end interface using Flask. This interface allows for easy user interaction with the system, providing a platform for testing its performance. With secure authentication, users can safely test the system and evaluate how will it classify web services. This combination of this improved algorithms and user-friendly design ensures that system not only performs well but also accessible for hands-on evaluation and feedback. Moving on to the implementation of the project, we have followed the steps which are mentioned in the flow of work. So the first step is importing the packages. First, we import all the required libraries and packages for data manipulation, machine learning, or to build the machine learning models and to develop the front end. And then comes the data exploration part. So this step involves analyzing the QWS dataset to understand its structure, contents, and relationship between different features. It helps in identifying the relevant aspects for the classification. Then comes visualization part. In this step, graphical representations like histograms, scatter plots, etc. are used to explore the distribution and patterns in the data, which aids in understanding, identifying trends and outliers, and also the correlation. Then comes the data processing. So here, the first step is we remove irrelevant columns. So columns that don't contribute to the prediction like IDs or irrelevant attributes are removed to improve model efficiency. And coming to handling missing data is addressed by removing or filling in gaps with the appropriate values. And then comes shuffling the data set. The data set is shuffled to ensure that the model is trained on the random subset of the data, improving the generalization. Coming to feature selection, in this step, the features that are independent variables are separated from the labels that are dependent variables to train the model. The features are stored in X variable and the labels are stored in Y variable. Coming to data splitting, the pre-processed data is split into two parts. One is training set and the other one is testing set. In training set, 80% of the data is stored and the remaining 20% is stored in the testing set, which is used to evaluate its performance. Coming to model initialization, this step involves selecting and initializing the machine learning model that will be used for training and prediction. Coming to model training, so in the model training step, the model is trained using the training data set where it learns the patterns in the data and adjusts its parameters accordingly to make the predictions. Then comes performance evaluation. After model has been trained, it is evaluated using testing set. Metrics like accuracy, precision, recall, and FN score are calculated to assess the model performance, and they are compared through the graphs. Coming to the front end, this step involves s- building a user-friendly web interface, which is created using Flash framework, allowing users to input their data and interact with the system. Registration and login functionalities are set up with the SQLite database for secure access. And the next step is user gives input as feature values. So the user provides input values such as feature values through the front-end interface for the system to predict the class of the web service. Then the input provided by the user is pre-processed to match the format required for the prediction, ensuring the data is consistent with the training data. The pre-processed user input is then passed to the trained model to make predictions on the web service classification, and the results are displayed to the user through the front end of the application. And moving on to the algorithms used, these are the algorithms which are used for classifying the web service. And to implement this project, we need basic requirements, which are hardware and software. So coming to hardware, we need operating system of Windows, processor of i5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. Coming to software requirements, we need application of Anaconda, Front-end framework of Flask, back-end framework of Jupyter Notebook, database of SQLite 3, and front-end technologies are HTML, CSS, JavaScript, and Bootstrap. Let's again check what are the algorithms used. So we have used decision tree, support vector machine, logistic regression, random forest, MLP, XGBoost, and the proposed model is SSL WSE it is built. And also the extension model CAD Boost has been trained on the QWL dataset to classify the web services that are platinum, gold, bronze, and silver. So this is the overview of the project. Now we are supposed to execute. To execute, we need to open the code folder that contains source code files. So let us open the code folder. These are the source code files in the code folder of the project. Let us understand each of them, how will they be used in this project. In the dataset folder, we have two files. One is QWS1 and the other one is test data. In this, we have the dataset that is used to train the models and predict the web service classification. And in this test data file, we have the test cases that will be used in the front end to predict the web service classification. And in this model folder, we have .h5 files, numpy files, and pickle files. In that, algorithm information is stored and that will be loaded into the project code during runtime of the application. And this is the static folder. This folder consists of files related to CSS, JavaScript, and Bootstrap files, which are important for the visual appeal. And coming to the templates folder, this folder contains all the HTML pages used in this project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. And here, app.py file is the .py file containing the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in HTML templates. And this is the notebook.ipynb file. This is a Jupyter notebook file which contains the combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, which makes it a popular choice for the data science. And the last file we have is the signup.db file. This file is a database file which is used to store the user information. So we understood all the things of code folder. Now let us execute. For that, we are supposed to copy the address of the, we need to copy the path of the code folder from address bar. So I'm copying the path. Now open the command prompt. So it has been opened. Give the command cd and now give the space. Paste the path which we have copied now. And now click on enter. So here if you observe, current directory is changed to the code folder's path. So now give the command python space app.py to compile app.py file. Click on enter. So this command will execute Python script and perform a runtime check for any syntax errors or logical issues. And after running this app.py file, Flask framework will host the application locally at the default address, which is the local host and the port unless configured differently. Now we are supposed to copy this local link provided by the Flask framework and paste it in any web browser. I'm copying the link. I prefer Google Chrome, so I will paste it in that. Paste the link here, click on enter. This is the web page of the project which is displayed in the browser. We need to sign up for doing the prediction. Click on that and enter all the registration details if you are registering newly. I have already registered, so I will directly sign in. Click on sign in and give your username and the password. Now click on enter. We have signed in successfully and we are redirected to prediction page of the project. And here you can see a box, right? In this text box, we are supposed to provide the input. So we have those inputs in the test case file in the dataset folder. So let's open the dataset. In this, we have the test cases. So these are the different attributes that we are supposed to give as the input. Based on these only, we will be getting the web service classification, whether it is platinum, gold, silver, or bronze. So first, let's understand what are these parameters are. First parameter is the response time. This refers to the time it taken for the web service to respond to a request. Shorter response time typically indicates better performance as the service quickly processes and returns the requested data. And then we have is the availability. This measures the uptime or the percentage of the time the web service is accessible and also operational. Higher availability means the service is consistently available without frequent downtimes. Then we have is the throughput. Throughput refers to the amount of data the web service can handle within a given period. Higher throughput indicates the service can process large volumes of requests or data efficiently. Then we have successibility. This parameter measures the probability of a web service successfully completing its task or fulfilling requests without errors. Higher successibility means fewer failures or issues. Then we have reliability. Reliability measures how consistently and predictably a web service performance performs over time. A reliable service operates without frequent breakdowns or performance issues. Coming to compliance, so this refers to the web service adherence to relevant standards, regulations, or legal requirements. A complaint service ensures it follows necessary guidelines and industry best practices. Then we have best practices. This parameter evaluates whether the web service allows follows established industry best practices such as proper security protocols, code quality, and efficiency standards. Coming to latency, it is the delay between sending a request and receiving a response. Lower latency indicates a faster web service, providing quicker interactions for the users. Then comes the documentation. So, documentation includes the resources, guides, and instructions provided by the service. This helps users to understand how to integrate and use the service effectively. Well documented services are easier to work with. And the last column we have is the WSRF, that is Web Service Resource Framework. It is the framework for building and managing web services, particularly for resource management in distributed systems, and it enables the creation of services that can efficiently manage and expose the resources. So this is all about the parameters. Now we are supposed to give the input. So let's copy the first test case. So copy the values, get back to the application, paste the values here. And where do we have spaces? Wherever we have spaces, give the comma. So I'm giving the comma for all the attributes. So I have given comma to all the values. Now click on upload. So this given input will be pre-processed at the backend and then it will be fed with the trained model and then we will be getting the prediction. So these are the values that we have uploaded and here we got the classification performance, and that means web service has been classified as platinum. So based on the given input for that particular web service, it has been classified as it is a platinum web service. That means it is a good performing web service. Now let's try with the one more case. So let's copy the second case, copy it, get back to the application, paste it and give the commas. So I'm giving the commas. Now let's see what are the predictions. What is the predictions for this given input? Now click on upload. So here we got the prediction that the web service is gold. Based on the given input provided, the web service has been classified as gold. So it means it is performing well. Now let's check with the one more case. Let's try with this case. We have copied the two set of values. Let's copy this one, get back to the application, paste it and give the commas. I've completed giving the commas. Click on upload. And here we got the prediction as silver. So for the given input features, here we got the prediction as the web service has been classified as silver. Now let's check with the last case. Let's check with this case. Get back to the application, paste it. I'm giving the commas. So now click on upload. Here we got the prediction that it is the bronze. That means it is not that well performing kind of web service it is. So that is why it has given us bronze. First comes the platinum, then comes the gold, and then third place will be silver, and the fourth place would be bronze. So the given input details of web service would be bronze kind of service that it is providing. Now let's check with the graph. Click on graph. So here, the first graph which we have is the confusion matrix graph of the extension model. Here on x-axis we have predicted class and on y-axis we have true class. And this diagonal represents the true classifications and values which are above the diagonal and below the diagonal are the misclassifications. And this is the accuracy score comparison graph. Here on x-axis we have accuracy score and on y-axis we have all the algorithms which are trained on QWS dataset to classify the web service. If you observe, extension model has the highest accuracy. Moving on, this is the precision score comparison graph. This is the recall score and this is the FN score. So accuracy, precision, recall and FN score are the evaluation metrics which are used to evaluate the model. Now let's click on sign out. In this widget, by giving the required input to the application, then application will classify web service whether it belongs to platinum, gold, silver or bronze. So this is all about the project.
Thank you for watching video. For more projects please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.